Let's eliminate the constant a from this given equation, and let's use here the concept of derivatives in order for us to find ways to remove the said constant a. Let's start by taking the derivatives of both sides of the equation. So that would mean, and take note that this is with an exponent, so we're going to take the derivative of that by using the chain rule. So we'll have this form. You have twice x minus a, and of course 2 minus 1 is just 1 as an exponent, so it's just like that, times the derivative of the expression under the exponentiation. That's why you will have here 1. Then take the derivative of your y squared, so you will have here 2y, but since we are taking a derivative of y, so let's try to have it here y prime, or you can have it as a derivative of y in terms of x, the symbol dy over dx, but let's just have y prime in this instant. And this is equal to, since we are taking a as a constant, not a variable, so the square of a constant is a constant, and the derivative of the constant is just equal to 0. So we have now removed the first constant a. Let's continue. Of course, you will have here twice x minus a plus twice y, and y prime equal to 0. Let's distribute 2, so you have 2x minus 2a plus 2y, and y prime is equal to 0. Take note that we are trying to eliminate a, so let's move the term with a on the right hand side. So you will have here 2x plus 2y, y prime is equal to 2, and then a. Since we have the constant 2 on all terms, we can divide 2 on all terms here. So you have x plus y, and then y prime is equal to a. So with this in mind, we are now trying to consider the value of a. Let's try to substitute a on our given equation because we would like it to be eliminated. So instead of x minus a, or the square of it, plus y squared, which is equal to a squared, let's use this expression for a. So you'll have this form. You will have x minus the given expression for a, x plus y prime. The result of that will be squared. Okay, I could use this symbol here. Plus y squared is equal to the square of this expression, y and y prime. So since this is just under grouping symbol, you can simply remove that, and then you will have here this form, x minus x, then negative y and y prime. Take note of that. You're removing grouping symbols. Plus y squared. This side, you will have to use the square of a binomial. You have x squared plus twice the first term and the second term, and then plus the square, or let's just simply use this. Okay, let's use okay, y and y prime, and then you square that. Okay, now this is removed, so the square of this expression here, this expression will just be equal to, or let's just, it's now positive. Okay, let's just do it in this manner first. Y squared, and then you have the square of your first order derivative plus y squared, still equal to the other side, x squared plus twice xy y prime, and you have the y, the square of the two expressions. Or you can again do the same thing that you did on the other side. You will have y squared times the square of the first order derivative. Okay, since we have this on both sides, we can remove that immediately, leaving y squared on this side, and the other side is x squared plus 2xy and y prime. Okay, so this is now the next form of our equation. We can just simply transpose everything on the other side, or do it here, and of course by symmetric property you will still end up with the equation x squared plus, or let's have minus y squared, and then you have plus 2xy y prime is equal to 0. Or as mentioned earlier, you can rewrite in this manner, 2xy, and you have here this symbol for derivative of y in terms of x equal to 0. This is now an equation without the variable a. And this is actually already acceptable form for our process where we involve a certain removal of constant. You can actually continue this. You can transform this into an expression with separable, which is a separate differential equation. You can multiply. Let's just copy it here. I'm just explaining this in advance, but this will be tackled by the next few videos. Okay. If we are going to multiply dx on both sides, you will have this form: x squared minus y squared times dx plus 2xy dy equal to 0. Okay, this is also another form, and this might be used in the next few topics in our next few videos for this specific playlist. But nevertheless, from here to here, we have now eliminated our arbitrary constant a. Thank you very much for watching.